Hello viewers, in today's class we are going to take up one important and interesting problem from cubic equations, right? And here we have a very nice problem, that is if alpha, beta, gamma are the roots of the equation x cube minus 3x square plus 8x plus 2 is equal to 0, then we have to find the value of this expression, that is alpha square plus 4 multiplied beta square plus 4 multiplied gamma square plus 4, right? So here we have to find the value of the product of these three terms, right? And here we have the cubic equation, and alpha, beta, gamma are the roots of this cubic equation. So here without finding out actually the values of alpha, beta, gamma, we have to find the value of this expression, right? So here what we will do, will make use of the concept of complex numbers, right? So here we are given this equation, that is x cube minus 3x square plus 8x plus 2 is equal to 0, right? And alpha, beta, gamma are its roots. So this cubic polynomial can be written as, we can write this cubic polynomial as a product of these three terms, that is x minus alpha times x minus beta and x minus gamma, right? So we can write this cubic polynomial equal to the product of these three linear factors. So here this is an important step over here, right? So now what we will do, we'll take x is equal to 2i, right? Where I is the complex number, that is iota, and I is square root of minus 1, that is I square is equal to minus 1, right? So here we'll make this substitution in equation number 1. So now when we take x is equal to 2i, we'll get 2i cube, and here we have 3 times 2i square, here we have 8 times 2i, and here we have plus 2, and here we have for x we can write 2i, right? So we have 2i minus alpha, then 2i minus beta, and here we have 2i minus gamma, right? So now let us simplify this expression. So 2 cube is 8, and here we have I cube. I cube is I square minus I square times I. So I square is minus 1, so we have minus I. So here we have minus I, and here we have 3 times. This is 4I square, so this is negative 4. And here we have 16I, and here we have plus 2, and this is 2i minus alpha, 2i minus beta, and here we have 2i minus gamma. So now let us simplify this expression, right? So here we have minus 8i, and this is plus 12, and here we have 16i, and here we have plus 2. So 16i minus 8i is equal to 8i, and 12 plus 2 is 14, right? So now 8i plus 14 is equal to this expression, right? So now we can write 2i minus alpha, here we have 2i minus beta, here we have 2i minus gamma is equal to 8i plus 12, right? So now see, here we have the product of three complex quantities, and here also we have a complex number of this form, that is a plus iota b, right? So now from here what we will do, we'll take the modulus or the magnitude of both the sides, right? So now taking the magnitude of these two sides, because these two sides are complex numbers, so we can now write here 2i minus alpha, 2i minus beta, and 2i minus gamma. And here we have the magnitude of 8i plus 14, right? So here we have the magnitude, right? So here we'll make use of an important result from complex numbers, that is the magnitude of a plus iota b is equal to square root of a square plus b square, right? Or we can write a plus iota b, the square of the magnitude is equal to a square plus b square. So now we can write this side as magnitude of 2i minus alpha. Then we can write 2i minus beta, the magnitude of 2i minus beta. And here we have magnitude of 2i minus gamma. And here we have the square root of 8 square plus 14 square, right? Now here we have used an important result from complex numbers, that is if we have magnitude of the product of three complex numbers, that is z1, z2, z3, then we can write magnitude of z1, then magnitude of z2, then magnitude of z3, right? So now the magnitude of 2i minus alpha can be written with the help of this result. So we have square root of 2 square plus minus alpha square, that is square root of 4 plus alpha square, right? And similarly here we have square root of 2 square plus minus beta square, that is 4 plus beta square. And here also we have 2 square plus minus gamma square, that is square root of 4 plus gamma square. So now this equation can be written as square root of 4 plus alpha square times square root of 4 plus beta square times square root of 4 plus gamma square is equal to square root of, this is 8 square, that is 64, this is 14 square, that is 196, so this is 6 plus 4 10, and this is 9 plus 6 14 15, then 6, and here we have 2, right? So we have 260, right? Now if we take the square of both sides, then we'll get 4 plus alpha square, here we have 4 plus beta square, and then we have 4 plus gamma square is equal to 260, right? So now we can write this expression as alpha square plus 4, beta square plus 4, and then gamma square plus 4 is equal to 260, right? So viewers, the value of this expression is equal to 260, right? So this is how by making use of the concept of complex numbers, we can find out the value of this expression.